Hey everybody, this is Larry. This is June 26th of the year 2024. Here I will do an algo prompt I haven't done before. So an RNG one today. Just keep it a little bit easy. I'm a little bit tired. Yeah, let's get to it. 1177 can make Palindrome from Substring. You're given a string S and you have queries 330. You may rearrange to choose K or I of them to replace with any. What's K? Oh, K is, they give you K. Alright, if substring is possible to make a palindrome after the operation, first. D is a palindrome, BC is not a palindrome with 0, okay. Okay. I think the biggest part about this one is just pre-processing and figuring out how to get the queries, and then after that it just becomes pretty straightforward, right? So I think maybe straightforward is not the right word, my apologies, but yeah, I think the biggest thing is just kind of just figuring out how to get the queries for each query to get the what's the count of each substring. And the thing with for each character, the reason why is because the substring itself doesn't really matter because we get to rearrange, right, for this particular problem. And so you only really care about the count. Like for example, this contains 1A, 1B, 1C, 1D, and can you make a palindrome from it? And here, this is where we just have to kind of go through what a palindrome means. And a palindrome in this case just means that each character appears at most, each character appears even number of times, except for one of them, which is odd, up to one of them, which is odd. And the thing with k sub I, or updating k, means that in a way, we get to cancel out two odd ones, right? Because for example, if you have A, B, C, D, if we could change two characters, then we can get rid of two of the odd ones with one change, and then the second one with the second change, right? So that's basically the idea that I would think about, and then hopefully that's all the edge cases. I'm trying to think through whether that is true, but I think that's true. So yeah, so go ahead. So for the queries part, I think there are two main ways to do it. One is to store the index of each character in its own thing, and then just do 26 binary search on the queries. The other way to do it is just having prefix sum. The trade-off is basically space versus time, right? The binary search one will take all of n times because you're just keeping all of one item per index. The prefix sum method will take all of alpha times n, where alpha is the size of the alphabet, right? So that it is going to be 26 times more space, but the benefit is that you can enter these in all of alpha, which is for each character you can do prefix sum calculation. And for the binary search one, it's going to be O of alpha times log n, which is going to be log n factor more expensive. So you can in theory do the math for it, but I'm just going to do it the prefix sum way. And the idea behind prefix sum is just that to get a query between the prefix sum idea is that if you have a count of let's say prefix sum of x or of I is just equal to count of 0 plus count of 1 plus count of 2 plus ... plus count of I, right? And then now P of J, where I is greater than J, or J is less than I, right? In that case, P of J will go to the same thing, right? Except for then now, here, because if J is less than I, you could do ... plus C of I. So then now, and of course this, now if you want to get the range from, why is there a comma? if you want to get a range from I to j inclusive, or j to I inclusive, because j is the smaller one, then now it's just p sub I minus p of j minus 1, because then now if you have j minus 1 here, if you subtract the top from the left, you just line them up, right? Or this is all gone, this is all gone. So then now you have the count of j plus all the way to c sub I. So that's the basic idea of what we call prefix sum, or I call prefix sum anyway. And yeah, so then now we can pre-process it for each character. So we will do that by having just like a count thing is equal to 0. We times it by 26, just one for each character. And then we do it for each of the n. We have an extra one just so that we start at 0 at the very left. And then now we have for I in range of n, so s sub I is going to be the character, right? We want to convert it to just 0 to 25. So this is the index. Maybe I call it A for alphabet. And then C of A is going to be equal to, or C of I plus 1 of A is equal to C of I A plus 1. And yeah, and then for the other ones, you just copy. So maybe for J in range of 26, C of I plus 1 of J is equal to C of I plus, yeah, something like that, right? Hopefully this makes sense. Basically, we move the prefix sum all the way over from I to I plus 1, except for the one where this is the current character, because you add 1 to it. Pretty straightforward, I hope. If not, then my apologies. But yeah, then now we can answer each query, right? So maybe we have an answer array for, what is it, left, right? Are they always left, right? Left is left. Okay, just want to make sure, because sometimes there are problems where they try to trick you with the edge case there. So that's why I double check. But yeah, and then now we can just do C. Okay, I mean, it's not that bad. It's just that for J in range of 26, we have C of right plus 1, J minus C of left, J. So this is the character for character J. So then maybe we have a count. So maybe we just keep track of odd count, right? So if this mod 2 is equal to 1, then odd count we increment by 1. And as we said, every two, each k allow us to do 2 things, right? Or like get rid of 2 odd ones. So basically, if 2 times k is greater than or equal to odd count, then we're good. But remember, we get to keep 1 odd count. So then here, so odd count minus 1. If 2 times k is greater than it, then answer that we append true. Else, and of course, I know that this could be a one-liner, but I just want to write it out just for better visualization. But maybe slightly anyway. Yeah, so it looks okay. Let's give it a quick submit. Hopefully, I haven't done this one before. Oh yeah, of course we haven't done this one before. We searched for that reason. But yeah, yeah, pretty cool, pretty straightforward. Can we be a little bit smarter? This view is a little bit slow, but I think that is fine. So what's the complexity here, right? For each query, as we said, we have O of 26, and that's it. This is going to be O of alpha times n space, where alpha is the size of the alphabet. I used A because I don't have a Greek keyboard. So this is O of alpha time and space for this part, because it just takes you that long. This is going to be O of Q time and space. Well, O of Q time. No, O of Q space. O of alpha times Q time, right? So in total, this is going to be O of A times N plus A times Q time. and O of A times N plus Q space. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.